test. All right, I'm live.
I'd like to introduce our next speaker, Kridner, who is a senior at Texas Instruments with many years of experience doing embedded processors, and is also a driving force behind the Beagle phone, Beagle board, PocketBeagle ecosystem as one of the founding members of the BeagleBoard.org Foundation, and a big enthusiast of attracting makers and learners of all sorts to the open source world through this Beagle platform. This is going to be a good opportunity for some Q&A with the senior engineer. He doesn't have a lot of slides, so have a lot of good questions, guys.
Yeah, I won't go into my personal life horror stories and stuff, but I spent all my time preparing the slides for the talk this morning on the PocketBeagle walkthrough. If anybody was in that, but it didn't look like many familiar faces. But next door they're giving the embedded apprentice Linux engineer training where they're using PocketBeagles and these add-on boards to teach people about developing with Linux. And I am spending my time there. This presentation was one that I was originally I'm going to give it this next week at Embedded Linux conference. But unfortunately, I was planning to already have the slides done by now, but I don't, and I was just going to reuse it. So forgive me, I don't actually have any slides. But if you want to walk out, I'm not going to be offended. But I will try to show you some of the things about Netconsole. I don't have it working in this setup, but I can show you where some of the gaps are and some of the things that allow you to get there when I have all the rest of the. Anyway, I've got a couple nights of work ahead of me still. But if you've never heard of Netconsole, it's generally a way to use a network interface to do serial type of tasks. All it is doing is sending UDP packets, pretty much raw text in UDP packets for the data, and that could be all sorts of different. But the Linux kernel, it's the console messages for the kernel log. So everything is printing out gets sent out across a UDP port that's pre-configured. For U-boot, which I think is in a lot of ways more interesting for the in the early boot phases and more the somewhat more challenging part. Netconsole is that interactive portion of the bootloader. So you can actually you can specify to do TFTP. You can specify to do all those things using UDP packets, and you would just use a tool like Netcat. If you've heard of it, seen Netcat. How many people have heard Netcat? Okay. Yeah. You showed up to a Netconsole talk because you're actually ready to learn about C Netconsole and things working. So yeah, you can use Netcat and you can just the port 6666 and you can start interacting with the U-boot console there directly from Netconsole to see the commands coming from U-boot, right? And you can type your commands and do things. The extra little bit that I'm really trying to add here is doing that all over USB, right? So if you we've got on this one so this is the PocketBeagle. So it's a little Linux computer. Running powered off the USB cable, and that USB cable also, so it's connected to the gadget controller on the or OTG controller on the processor. So I can actually, and the ROM has a bootloader, so let me just take my disk out, right? So normally it boots off of this micro SD card, but the interesting thing is when you start booting it off of the USB. So I've got a little Node.js app sudo npm that essentially implements. It uses uses the Node USB, or it essentially uses libUSB, if you're familiar with libUSB, that gives you an API to directly initiate packet transfers. You know, so you can say, I want to do an in transfer, out transfer, you know, a config, you know, sort of transfer. So you can do all the individual transfers from the API rather than writing a driver for it. You're doing everything in user space. So with Node USB, it's just doing that exact same stuff in JavaScript. May not be your choice, but the idea, I'm trying to put this stuff together so we actually do it with the new web USB stuff. So the overall objective is to be able to boot your computer off of your web browser, and then even to go to the point of seeing the U-boot traffic in your web browser, right, and being able to interact with it that way directly from just the ROM on the processor. That's where we're headed. I type my password in right. So this is that little daemon. And you could kind of do the same thing all with services, right? You don't necessarily because what I'm doing is, instead I'm grabbing that USB device here. I could let it get enumerated by the computer and look at it as like a network device and do things that way. But instead I'm grabbing it here to be able to put it all into that sort of web USB framework. But it's essentially a TFTP server, right? So the ROM code on this processor actually comes up and says it is a network device, and then will allow you to TFTP code to it. So we TFTP SPL to it. Then once SPL is loaded, SPL TFTPs, or it loads another USB driver and it TFTPs U-boot, and then from there it you know, you can interact with it via Netconsole, or you can boot to the kernel. SPL is the secondary program loader. So it is U-boot. It's a different compilation of U-boot. So it goes through a different set of if-defs and different linking, such that it trims it down to a much smaller version. So it's a U-boot meant to load U-boot. It doesn't have things like the command line, you know, that you could run different. You know, it's more fixed purpose. The reason that it exists is because for some of these processors, including this one, you need to configure external memory with some initial code before you can load into that memory. So the bootloader itself doesn't, the ROM bootloader doesn't configure that external memory. So in our case, that's exactly what it is. So it all fits, the SPL will fit entirely inside the internal RAM of the processor, configure the DDR that's sitting external to the processor, and then that SPL can then load U-boot that's bigger than what the internal RAM is on the processor. MLO and SPL are the same thing. MLO historically is a TI name. It's the new name for, yeah, MLO is the new, so yeah, there was it came from a proprietary approach, which was so the TI developers started with U-boot and they stripped it down into an internal version that loaded U-boot, but then it got pushed upstream, and the MLO, I don't even know what MLO stands for, but the ROM code actually looks, if you on an SD card, if you're booting from FAT, it'll look for a file called MLO. So it looks for a file with that particular name, but the file is SPL. And did I say that SPL is secondary program loader? I did, but I don't know what MLO stands for at all. Yeah, right off well, and it's just meant to load. It's meant to load the primary one here is U-boot. So we have the ROM. ROM is first. The tertiary. Yeah. Okay. I couldn't. We need Tom Marini around to answer that one. Oh, is it? Oh, but that's the hands-on U-boot. So I'll just show you that. So that's doing the boot P, and you know, it'll be sitting there in U-boot right now. And so it's not very interesting. U-boot is trying to boot, and so like some of the default configurations it has is to try to TFTP this .exe config file. That's just part of what mainline U-boot does. I don't know why it's trying to do that. My little program doesn't have any idea how to handle that. So normally I would stop it beforehand. Let me go ahead and bring up the serial port, which is the whole thing that I'm trying to get rid of. But the way you would normally interact with U-boot is you would have a serial connection to be able to work with. And for people doing development that are kind of new, I don't want them to have to go and buy a whole bunch of other hardware and figure out how to configure things just to just to be able to read boot logs. They should almost never have to do. But in the case they do, we want it to work all over the USB. Pseudo screen. Oh no, it's what's it? You have to put the baud rate after it, so it happens to be 115.2. Hope that's the right location where this guy enumerates. I probably should have looked at my message log first. There we go. So I'm gonna just pull the power here. It's about to start rebooting again. My little daemon is gonna sit there running in the background now. No, not what I wanted. My little daemon's gonna sit there and run in the background now, but oh, it's kept the power up because the serial port has power now. So I'm gonna just hit the reset button, and again, so the ROM grabbed the SPL. Okay, and that time I stopped it. So at this point we're inside of the U-boot command line. So what's run here is Control A. So if we go back to the very beginning of the boot, on the serial output, we see this. Where's the very first line? Here we go. That U-boot SPL line. So so SPL will print something out that says I'm going to try to boot from USB Ethernet. It tried to look for environment on the FAT. Of course, I have no SD card attached, so it's not going to find any environment variables saved off in the FAT. And then it ends up getting the U-boot load. Question? Yes. Yeah. And the boot ROM itself on this particular device it includes that it looks like an USB RN-disk device, and it tries to do an ARP and a boot P. So you'll get a boot P request and then an ARP request, and then it'll start doing a TFTP transfer. So that first part was satisfying those requests by the ROM code, and then the second part was satisfying those similar requests from SPL. You could then go from here if we wanted to TFTP the kernel. We could use the same daemon to TFTP the kernel or TFTP a root file system. So I mean that part is pretty well handled. What's not handled is the debug part, which is why the Netconsole part is really important. So as long as all that works, you're great. But if you're trying to develop a new kernel, you're trying to develop a new, making changes to U-boot without having the serial port, you're not getting any real feedback. You're just not getting the packet request, and you have no idea why, or you're not getting your kernel to boot up. when you want to do Netconsole, essentially it's pretty straightforward. You have to compile a few variables in the configuration you say enable Netconsole, but from a practical standpoint in U-Boot, you also want to probably have the thing that allows you to mux the output. So it's possible to have multiple consoles in U-Boot, and maybe eventually I'll just switch over to all Netconsole, but typically it's serial. So if you print, so like you'll see these, and I don't know how many people how many of you played with U-Boot's command line very much, right? For most part, people would say, okay, well, U-Boot needs, it loads my kernel, I'm happy, everything's good, well and good. But it's actually a very, very flexible programming system that it's got in here. So you can print, you can do help, get a list of all the different commands. There's a lot of different commands. You can find out different version information. So you can query quite a bit. If I wanted to be able to turn this into like a USB dongle, I actually run UMS right from here, which means USB mass storage. So from this, I wouldn't have to have an SD card writer that's separate. I could actually just straight from U-Boot, I could run UMS. Help. Maybe I don't have UMS compiled into this version. Yeah. So if you run the USB mass storage thing, you can actually just use it to serve up the card and write it directly from the card. That's another aspect of what we were trying to do here, is so we can use the web USB and it'll automatically down the images and program it. There was a question or comment? So the device tree. This is super useful stuff if your system's not booting because you tried to load the wrong driver or other things. So U-Boot has the ability to patch the device tree. So the device tree is the thing that describes all the hardware to the kernel, and so for each of the different target boards, you'll have a device tree. That gets loaded at the same time as the kernel. So the bootloader will load that. For Beagles, we also have an overlay scheme where we'll look at a bunch of different variables that you set up in a text file and use that to load different overlays. And U-Boot will actually apply those overlays for us. So when the kernel boots, it's all just set up and running. There's also ways to dynamically do it in the kernel, but for things like, oh, I'm adding on an LCD, I would like for just the LCD to actually, show the boot messages or something like that. You want to have it very early on, so you can do that in U-Boot before the kernel ever loads. So you can modify this data structure that describes the hardware to the kernel. Yes, all things that would be really nice to do without having to go get a serial adapter and There are a number of things that I found that I can't do in the kernel that I can do in U-Boot. One is, so even if you have like a fleshed out device tree, like I don't think there's a way to easily, I see remove nodes, but honestly I really struggle in any sort of editor to really remove nodes practically. But it's pretty easy to go and add a status equal disabled to an individual node so that when the kernel loads, it doesn't load that module. There's a number of hack modules essentially in the world out there that you might want to load that don't unload themselves properly. So anytime if you try to do it dynamically in the kernel, it needs to have the remove module support done properly. Yeah, and the config.fs approach is how I'm doing it now on PocketBeagle. So as far as like live patches, but we just generally discourage people from doing live patches, instead do the patches as U-boot. But there's a few places where I'm showing people how to do the live patches with config.fs. But the Cape Manager is not part of PocketBeagle. You're pretty quiet. I know the rest of the room. I'm sure the rest of the room can't hear you. The advantages of config.fs over what? For the most part, people using it really aren't doing editing. They're just wanting to use it, and so that way they can have it at boot up. It's all just running. You know, it's persistent, right? When you edit the config for U-boot, I'd say it is a challenge to try to do certain things. Like we now have in our default device tree for PocketBeagle, we load a bunch of things called pinmux helpers, and as well as we actually export a bunch of the GPIOs to sysfs, so we allocate those GPIOs to sysfs, so they're ready for users to do user spacey stuff to the GPIOs. But trying to disable those, like the helpers for that is all like one big thing, and it doesn't unload cleanly from the config.fs. But if we patch it in U-boot, it never loads. So we just set status equal to disabled as part of our overlays, and then we create, we export whatever GPIO pins we do want to export. So it's, there's a few cases where you really needed it to be in U-boot, and choosing one or the other, like the LCDs, like that was one of the biggest ones, was the LCDs.
Also, there was no interest from the upstream community to support doing this in the kernel.
Oh, it's not, well, but we have config.fs. It's already in the kernel when you talk about the config.fs. The Cape Manager, so one of the things that we do in U-boot now is we actually scan the EEPROM, so the Bone Cape Manager. So if you've heard of Cape Manager, it goes and looks at EEPROM values, looks for the device descriptor string in the EEPROMs of add-on boards for BeagleBoard, for BeagleBones. And if it sees that, it loads the device tree overlay, so associated with that board automatically, so it just dynamically like configures and goes at boot. We were doing that in Cape Manager at the kernel level, but now we're doing it at U-boot because Cape Manager, they didn't want to accept upstream. They've got dynamic overlays, but because I think a lot of it has to do with the terminology of calling the capes a bus. It's like, oh, that's not a bus. That's
the reason it's rejected is security.
Oh, right, yeah.
So, I don't think they like the fact that config.fs stuff got merged, because they view that as a security issue, which is unfortunate to us. This is why we had to go with the it seems like it's dead end from the kernel perspective.
I don't know if it's going to get pulled from the kernel, but right now it works.
It's in there, but to get anything else that utilizes the interface, seems like a dead end.
Yeah.
And the maintainers of that area don't seem to like the fact that that even exists. So that's what we're using. So there's, by default, it's going to run this, U-boot's going to run boot commands, which goes through this list of different boot sources and tries to look for some valid image to boot.
I don't know, we want to spend a whole lot of time going through U-boots, but I did want to, like, so the environment variables, standard in, standard out, right, they all say serial. If I put serial, comma, NC in those variables, that starts Netconsole. And usually, when I'm doing that, I've always created a variable that sets all three of them at once. I don't know if it really matters or not, but if there's a right order you can do it in, but I always set all three of them at once. So I do set environment, start NC, centered in. Oh, there's no equals, right? Yeah, so set standard in to serial, comma NC, standard out. Error, serial, comma NC. Now it's going to complain. It should complain because I haven't set the server IP or the my IP address. And this is where I need to kind of think about a few things. But like if I do run, start. And it crashed. And if you see that it brought the network up, but it says there's no IP address set. So I need to be able to set IP address before that. And it doesn't quite make sense to me. You can so we need to try to do something to fetch an address before that. And I don't know. There's a couple steps. I've had this running before, like 6 months ago. I had this running, but I was actually using this to do board testing. I was booting the boards over USB and using the Netconsole to issue commands. So I've got to pull that code up and try to understand everything that I did to get that again. But the reason I abandoned it at the time because it was too slow compared to booting off of the micro SD card. So it took a couple seconds to load up everything over USB, whereas I could be done in well under a second with micro SD cards. So I ended up doing all the board test, all the for the PocketBeagle testing was all done booting over micro SD and then using USB to send the serial number across. So we still make a USB connection and test the USB connection when we build the PocketBeagles, but we boot them off of the micro SD, which tests the micro SD card, and then we send the serial numbers to U-boot, but over the USB cable, not we don't boot it over USB. The serial number is so the serial number is going. I have to try to look at the code. The tester has the serial number and it's sending it to the board. The test code, I think, is still in a gist. I don't think it ever made its own repo. This is recorded, isn't it? Yeah, so it's here. So the test code looks this is the DTS file that I was using. So a lot of this stuff is also in this repo is also about bring up. So this is the tester code. So it's this JavaScript code, and so it's actually using Netconsole to send. Oh yeah, for sure. Is there a way to just increase the font or? So there's this JavaScript file is using Netconsole over U-boot. So U-boot boots up over the micro SD, but then it exports the Netconsole, and so I just listened for the UDP ports here in. I saved off my magic foo. I probably should have just copy and pasted right. But this is the magic foo for starting up Netconsole, where I've got I'm setting a server IP and a personal IP address, and then setting all the other items. But that's not the commands that I'm issuing. This is what it actually issues during the test. So it turns on an LED. This is the write protect signal. The GPIO is the write protect signal for the EEPROM. So it's tied to a line. Then I've got this script that sets up the EEPROM with a base header that's common across all the PocketBeagles. And then I've got this serial text, right? That's actually the serial number for the board. And then I'm doing what are these memory? Oh, I'm putting it into memory chunks at a time. And then I'm going to do a write of the whole memory dump, right? So here I'm doing the EEPROM write, I2C, of reading the data that I put into this location in memory. On the one, what is that? Is that the length? I have to look at the EEPROM write parameters exactly. That's the I2C address for the EEPROM. Address it's reading out of memory. The started offset 0, and I think 1C is the length. And then it sets another GPIO. If the write succeeded, I read it back. I set another GPIO to say that the write succeeded. I do a memory compare to actually see that the EEPROM value that I wrote is the EEPROM value that I read back. And then if that works, I set another GPIO, and we've got all 4 LEDs on, board good, ship it. So there's the testing here is, you've got the USB for all the communications, you got the micro SD card for doing that, plus you've got the EEPROM writing. So it ends up doing a number of tests on the hardware in order to get here. But this is what's being used to test all the PocketBeagles before they ship out. It's really not very well documented at all. There's a reasonable amount of stuff for doing Netconsole from the kernel, but when you start doing Netconsole and U-boot, it's largely undocumented. And my hope is to kind of bootstrap some of that and to kind of give a really good example. Unfortunately, I wasn't prepared today. You can definitely miss some of the early stuff. I think you need to set a reasonable boot delay in there to allow time for the interface to come up before you start doing interaction. Yes. Yeah. I will recommend that people doing this actually just do either both if they still want to be able to access the serial or as the default. There's a way to test if there's a network connection or not, essentially by doing the ping. And if there's no network, if Netconsole, so pre-doing the boot, we do a ping of the server IP, and if we can't ping it, we don't start Netconsole. I think for your individual target, it may not hurt at all. So you've been trying to ask for a while.
You normally do serial as a safety thing, but now you can serial over USB, then you wouldn't necessarily need that.
That's what we're trying to get to. But where the like usage is right now is everybody depends on serial. So until there's a lot of good examples, a lot of people coming to talk here with really prepared, showing people how they can do everything with Netconsole. Until that happens, you know, and lots of people are using it on a regular basis, I don't think the documentation and the examples are going to be clear enough for people to follow it enough. That people migrate away from using serial as their primary debug mechanism. Yes, and that's where I want to try to get to is, right. Let's not pay for the USB to serial adapter in order to have people be able to bring up Linux, and especially with something like what you've got with PocketBeagle, you've got that SIP on there that's, you know, pretty easy to lay out and make a board for. I think you can actually probably do it with a 2-layer board, which currently are a 4-layer board. If Michael's in the room, we'll have that debate. All you need is power and a crystal, and you still need to do some strapping of the boot config lines. You put resistors on there to kind of tell it what boot mode it should try, or what boot modes, because it tries 4 boot modes depending on what the boot config is. So you need that much hardware, but really nothing else. So you can get power and you can get the USB connection just from the USB cable. And so if you're trying to build your own board, right, you don't have a lot of other system dependencies. I haven't gone out, it doesn't matter what's on the other pins. I can boot up and run Linux, and then you know, from within Linux, I can go and try to turn on other things and like turn on a subsystem at a time and test it, see it works on the board. And go about that approach to bring up a new system, which is pretty different from the way people do it today. I mean, and although things have evolved a lot, and like when I started doing these in embedded Linux, everybody would have this. You start with the JTAG connection. First, you get JTAG, right? And then from JTAG, you start loading. Okay, I'm going to do some memory tests, make sure my memory's all right. Okay, memory is good. Now I'm going to go to the serial port. I'm going to get my serial port connection. I'm going to get that data going, right? And you build all these things up from these individual test code items that are personally hard to maintain and to move forward onto different platforms. So that's the way you traditionally would bring up a board. It's evolved somewhat now because there is a lot of open source support. There's still the initial processor bring up, but if somebody's already brought the processor, you can probably get to that serial port and do some other stuff there. But I think this takes it to a whole other level of simplicity. You can essentially do your board bring up with just a USB connection, providing your power, providing your communications, and everything else is, you know, then you can use Linux to actually running within a system, booting into RAM, to start going out and doing anything else sitting outside of that package. But also, you know, you want, you know, so I try to look at it both ways, right? What does the professional need, and what does somebody need to as a you know, a kid or a hobbyist or something just trying to get into it to understand what's going on in bootloaders and get that visibility. And if they can get it in their web browser, they didn't have to install any other tools, and you know, is less dependent on what that system is. Like that's to me sort of the magic. There are some tools to give you USB to get you browser to serial, but they still depend on external hardware and connections that, you know, aren't as trivial as, you know, this is the one connection to the board. So anyway, that's where I'm trying to get to, and we've got the Node.js project. But I think the big thing we have to kind of make a change is get people using Netconsole, because it doesn't get used enough to get really debugged and fleshed out. And maybe I'm wrong, but I haven't heard anybody here actually using Netconsole on a regular basis. Anybody use it on a regular basis? You've used it? at the kernel or at the U-boot?
Both.
Both. Oh wow. I need to. Why haven't you done this presentation? If you had some documentation, like something write up on that, that'd be extremely interesting. The gentleman with the Netconsole, he looks familiar, but I don't. Do you? So what do you use Netconsole for?
Well, we had previous life I worked at a so we had a lab full of switches running.
So you can't go wire up serial cables to every single board. Yeah, but you've already run the Ethernet, so. And did U-boot? Were you using U-boot? You didn't, but you didn't do Netconsole in it. Yeah. I mean, doing it in the kernel is not that uncommon. Doing it in U-boot, the support's there, but it's I mean, in terms of its function. But you can tell. I mean, I've done this a few times, and I still struggle with getting it set up right. Yeah, for the kernel, it's just because at the kernel command line, you provide all the parameters for where do you want the IP address of where you want it to be sent, and it goes. So it's just kernel command line. So, of course, were you telling me or asking me? You're probably so. You still have to get it up in the kernel, but there's a bunch of how-tos that are pretty good on just setting up the kernel command line. Especially if you can get into EFI, where you can actually run you can run some nice scripts from the bootloader to get things. If you can get into EFI, then I think you can do the configuration of the kernel command line stuff from there. I think it makes it really easy. Well, this doesn't have either. Right, so that's why we're doing it all over USB, which makes it a little bit trickier because you've got to get the drivers to come up first, and then you've got to try to get the services. Like if you're sitting on a static network, all you have to do is you have to have somebody running and listening for the ARP request, and the boot P request for when the device shows up on the network to get it its IP address, to get it its base code. It's a little bit different when you're doing it over USB. Yeah. So I don't think it's that much more complicated. It's just that there's a couple twists to it. I mean, so in this case, we have a ROM bootloader that knows how to boot over a USB. You're going to still need something that knows how to talk to the Bluetooth stack. If you really wanted to add something like that, there are some Bluetooth serial dongles that I think could be an interesting solution, but you're still depending on firmware within that dongle to support the serial connection and doing it that way. So at least you're not depending on software in your target. You're just depending on software in some external little module that you can control and replicate. But yeah, I don't know anything that's kind of got a solved just boot interface on Bluetooth. Maybe some 6LoWPAN experts will speak up. Thanks for coming by. I apologize for the lack of slides. If you have any other questions, feel free to come up. If you didn't want to shout them out, feel free to come up to me. If you have any PocketBeagle questions, I can certainly entertain those. Oh, one more. Yeah, for ELC. I can absolutely upload it onto the scale slides as well. So I'll make my slides over the next couple of days. And And yeah, so give it until after ELC, and then look, and the link should be live. My apologies. Yes. Again, feel free to come up to me afterwards, and I appreciate your understanding. Thanks.
It's not going inside the pocket. Because I have a giant belt thing back here.
Hey. No, please don't.
What?
Put it inside the pocket.
Why?
Because everybody I know who tells me don't put it on the inside of the pocket, here's what they do. And the next thing I know, it's a problem.
What do you mean it's a problem? It's not a problem. You guys can all hear me, right? See, they claim I... Does this work? No. No, it's not my headset. I don't own nice things like this. What happens if I do this? It sort of works, but I don't get the... And this is why everybody hates doing presentations from Linux. Well, some of us do. I still have like 15 minutes, so I'm just going to like be ridiculous and silly until then. So if you're welcome to leave if I'm being too silly. That is... yeah, Inkscape is excellent. That is true. I did not do my slides in that because... No. No, I'm not putting anything nice up there. Why would I do that? Let's see if I can get... They have to... They're the ones who have to look at it. I know what's on my slides. There. There. Ah! I have no... Oh, I mashed something wrong. I screwed it up. I know it looks fine, but it's just... It's obnoxious. I was hoping to get presenter view to work. Presenter view? Oh, maybe if I do this, can I full screen that? Start view, just click to present, click present. Okay, if I do that, and then I hit, what is it, F12? Oh, that's all right. Oh! I think I figured it out. There we go. Blah, blah, blah. Blah, 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 blah. Yeah. I was going to say, all of you guys are going to be able to hear me no matter what. It's whether they're going to be able to record this or not. Blah, 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 blah. Blah, blah, blah. Blah, blah. That sounds like I'm more coming out of the speakers. Oh, maybe this is a bad idea. Too late. Oh, wow, that actually works a lot better. Okay. I was wrong, Tom. The other mic was not as good. What? No, I was going to say the sound's fine for the most part. I don't think I'm too loud on your recording, probably. Yeah. Blah, blah, blah. Blah, 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 blah. IoT is broken. It's all broken. We're all going to die. I mean, life is a delightfully 100% fatal sexually transmitted disease, or as my wife likes to put it, since we just had a small one, her maternity leave was technically an STD. For those of you who are not American, STD being short-term disability. not the other way that should go. My wife's Canadian, so she found this hilarious. Oh, that's gonna be really obnoxious. Yeah, but I never stay put. If anybody has ever been to one of my talks, they all know that I never stand still. And this is why that little camera is gonna hate me. Oh, it's super. Oh. Oh. You knew I was gonna talk in here. I don't stay. Yeah, pretty much. I mean, PyCon's in Cleveland. I know. And I'm totally not sneaking into PyCon again this year. Hint, hint, I'm totally sneaking into PyCon this year, because that's what I do every year. Because I'm a Perl developer, not a Python developer. And they think I'm funny. So I have 7 minutes to tell jokes before you all start laughing at me. Wait, you try to laugh at me, or you... Wow, that would make this topic really, really boring and depressing. And this topic's already really, really depressing. That does look okay, right? I can neither confirm nor deny that there was a Warthog 1 through 8, and the bodies are totally not in places that you will never, ever, ever find them because they're next to Jimmy Hoffa. So the entire reason that the Raleigh-Durham photo was picked was when I did a Google image search with labeled for reuse, so that hypothetically, should my employer decide that they actually want me to talk about this subject internally, that I could still use these slides. That was the first one that came up that had that was pretty and had an appropriate amount of barbed wire on it. The rest of them got much more depressing, as it looked like they were military members actually stringing the barbed wire in much less friendly territory. And I didn't think that was quite what I wanted to go for. And my laptop decided it wanted to go to sleep. That's going to be interesting. Let's see if we can fix that. Who remembers where in GNOME that setting is? Power? My laptop is fully charged in 47 minutes. Power saving. Blank screen after never. That sounds about right. Oh, good, that didn't screw up anything. Empirical evidence in greater than 15 minutes, since the 15 minutes was the longest setting that GNOME would give me. So if it doesn't blank after 16 minutes, I'm going to empirically suggest that that is as close to never as I care about. Because never doesn't exist, only the heat death of the universe. So. Doop, doop, doo. Doop, doop, doo. I bet you this is Jason Kridner's water. I do always find it fascinating how awesome their recording gear is. If you're ever bored, they built their own hardware to do video recording for everything. So come sneak a peek behind the podium if you're ever interested or bored. Boop, boop, boo. Pretty solidly full room for 3 minutes out still. And clearly I budgeted way too much time to make Linux work on the screen again. I remember when I first started doing presentations and presenting on Linux, this is early 2000s. Trying to get the second monitor to work at all was a bloody miracle. We all knew magic incantations for xrandr. How many people actually have heard of xrandr? I'm sorry to all of you, you're all much too old. To the rest of you, feel sorry for the people who just raised their hands. Because the fact that we even know about xrandr is Yeah. Oh, that's right. I have fabulous prizes for this talk. I'm trying to remember the last time I actually did. I think... That's right. I have fabulous prizes that somebody may or may not want to win. Which will become apparent as I actually give my talk on why I'm giving this away. So somebody will either leave very, very happy or very, very sad, and I'm not sure which. It all depends on potentially how much you trust me. Because I'm a very trustworthy human being, right? Damn it. They know the secret. I'm screwed. My wife has a PhD in computer web security. So yeah, I'm probably not even remotely the most trustworthy person in this room. Yeah, she is much more educated than I am. Not that I'm complaining. That is true. She argues that her PhD is nothing more than her being far more stubborn than me, which is kind of impressive. Because you don't get a higher education degree because you're smart. You get it because you're so bloody stubborn that you actually make it through. As the people with higher education degrees all agree.
I have a bachelor's.
Yeah, I had a teacher at one point, since I have 20 seconds, try and convince me to go for my master's, and I said, you buy me hardware to break voting machines, and I will come back and I will do my my master's and possibly my PhD. He never bought me hardware, so I never went back. If you want to do my intro, you are welcome to do my intro, and that is a lovely machine. I have one in my backpack. Are you running Windows or Ubuntu? Okay.
John Hawley, who has been in the background on the kernel.org site on one of his earlier open source contributions that probably everyone in this room can thank for the continued running of that site over the years. He was leading the admin, but it turns out that he is a man with many hats, and he has a lot of hardware and embedded skills as well, and the hobby of putting drones on fire and other fun things like that.
I will set the record straight. The drones never caught on fire, but they did crash, because that's what drones do. And it was the robotic dog that caught on fire at scale 3 years ago. I made a replica of K9 from Doctor Who. Full size. Anyway, but that is not what this talk is about entirely. I'm here to talk about IoT and how good fences make good neighbors in this magical land of IoT. I am required to start out by pointing out that one of these people in the picture is a snowman, and one of them is me. And either way, that this entire talk is my opinions, my commentary, all of my blatherings and nonsense, not any of the views of my employer, who happens to be VMware, who was very kind enough to send me to this conference to talk to you guys about all of this. But let's start by taking a quick look at what the IoT world looks like today. I gave a talk last year where I commented, or where I made some interesting commentary about where is this IoT bus taking us. If you came to that talk, a lot of these pictures look familiar. If you didn't, this is a random smattering of all of the IoT devices that I have, not necessarily in my house, but that I have at least looked at from a perspective of how they work. And there's such delightful devices up there like your oven. It connects to the internet. That's not a bad idea at all. Your coffee maker, if you have one of these, make sure it is connected to the internet so that we can turn it off so you don't wake up in the morning. Pacemakers, that's totally good idea. Crock pots, again, totally good idea. Door locks. door locks have actually had a very interesting change in the last year, because a very large online retailer is now asking you to give them access to your electronic door. Is this not amazing? How could this possibly go wrong? I know. I actually get really excited by all of this stuff because it's so ridiculous. I mean, and to be fair, the very large online retailer, their motivations are actually well played. Because a lot of criminals have figured out, wait a minute, if I just wait for that weird white van that's not marked in any way, and with the person who has no indication that they're a delivery person, goes up to the door, and I wait 10 minutes after they leave, I can go steal all the things. Well, okay, so a lot of criminals have figured this out. And so they're trying to do is actually put your packages inside the door instead of just leaving them there for the criminals. Great. Except now that you're giving random strangers access to your house. Good job. It's not entirely ill thought out, but it does make some very interesting commentary in an internet connected world. I'm going to come back to that one. Your refrigerator, that's no more dangerous than your oven. Thermostat, again, really no more dangerous than your oven. Your TVs, this is always a really nice one. How many people have a TV? Okay, keep your hands up. How many people have a smart TV? How many of you believe that it's not spying on you? Oh, I have some news for you guys. and how many people have one of these magical smart speakers? How many of you have had it cackle at you in the last couple of days? Because apparently they're all cackling now. Because that's not super creepy at all. You're home alone. It's dark out. It's raining. I'm from Portland, so it rains all the time, so this is really easy. I also have coyotes that come in my backyard, so you hear a coyote wail, and then the Alexa device just starts cackling. Not creepy at all. Let's see, what else we got here? Yes, and cars. Internet-connected cars. Some friends of mine presented at DEF CON this last year and pointed out that several luxury-branded cars, down to and including some Nissan Leafs, which was the car that they were looking at, are actually vulnerable to the Haze modem attack that affected the iPhone 6 or iPhone many, many years ago, like 4 or 5 years ago. These cars were still susceptible to this attack. It's great. It means you can take over the entire car. You can turn the windshield wiper into the brakes and the accelerator into the horn and all kinds of stuff. And you know how this got fixed? The carrier that was providing the GSM connectivity to these cars decided to block the incoming port that would have connected to these cars. Would you like to know what port that was? 6667. And for those of you who are on IRC, you'll notice that that's the IRC port. So no more running IRC on your car. I'm sorry, guys. Or at least you have to do it on port 7000 now, not 667 or 6667. And then, we skew way off into the weeds, and then we look at, things like the Bluetooth-enabled pregnancy tester. And you wouldn't think that a pregnancy tester, this thing that you're literally going to pee on once and then throw away, would make sense as an IoT device. But it does, because it just so happens that this is a marketing ploy. Absolute marketing ploy. Because you know what the most profitable demographic is for marketers? People who are having a kid. Disclaimer, I just had one. So the marketing material is insane. If you have not had one, be prepared that just junk mail constant. And it gets worse, apparently. But yes, you install their app, and once it determines that you're pregnant, you just start getting coupons and spam constantly. No, for the record, my wife and I did not use that. We found out because we were going to India to give a pair of keynotes, and they found out when we were getting vaccinated. So, yeah. And then the last device on here, which I'm going to talk about quite a bit, are these things. These wonderful little devices that you plug into the socket, you plug it in your device, and it's got a giant relay, and it goes click, clack, and turns your lights on and off. Or your, let's see, your oven, your coffee maker, your crock pot, and anything else you can talk about, or you can look at here. But so these are a random smattering of all these IoT devices. And these are all coming to market as quickly as possible, as fast as they possibly can, and they're great, they're cheap, everybody's putting them everywhere. How many people do not have an IoT device in this room, in their house, running right now? I'm actually really impressed. I'm almost shocked, and you're probably lying, but I'll trust you. So, here are some really neat facts about all these devices that we're cramming into our houses. And these are news articles that I have pulled from within the last year. I decided that anything older than that, so like the original Mirai botnet and everything, was just a little too old to care about. The most recent of these was reported yesterday that shows that most IoT devices can be hacked into botnets. This is great. Look at all that neat cheap computational power that you're all buying for all the people who want botnets. It's great. The Bitcoin mining is going to get even slower because, trying to compute Bitcoin on this doesn't work very well and is not exactly profitable. But there's everything from, in 2017, distributed denial of service attacks increased 91%, mainly due to the rise of botnets on IoT devices, to IoT botnets bypassing firewalls to get at the actual firewalls themselves, so that once they've infected your network, they stay infected forever until you take that router, take it outside, put it under some thermite, and just nuke it into the ground and start over. And then hopefully you don't buy that brand of router again. IPv6, the problem's only going to get more complicated and harder, if for no other reason than IPv6 flattens the entire IP space across the internet. Right now we have these really broken things called NATed devices. Don't get me started on how terrible they are. That's an entire talk in and of itself. But once you flatten the entire topology of the internet, where I can now talk to this light switch directly, what's going to protect this light switch? This gets complicated very quickly. And one of the most interesting things, and one of the early things, was again a piece that came out of the Mirai botnet, which was the IP cameras participated in one of the largest distributed denial of service attacks at the time in recorded history. GitHub's last week eclipses that rather soundly, so to those of you who perpetrated that particular distributed denial of service attack, congrats. May you rot in the eternal fires of whatever circle of bad places that you would like to go to. But this is only going to get worse. And in the upper left-hand, or I guess in the upper right-hand corner for you guys, there's this ever-present now specter and meltdown that is now hanging over every device, whether it's your plug or your laptop, all the way up through the cloud servers, where we are now actively finding hardware bugs that are impossible, or fundamentally impossible to patch in some useful way. And this should scare the crap out of all of us. Because whereas, there are large companies who will try and ship fixes for my laptop, nobody's going to give a flying rat's patootie to try and fix the security bug when it's in my light switch. So, so there's some other interesting things going on here. So there's all these vendors out there. There's all these devices. And from a consumer perspective, I really want to control this device from anywhere. I don't know why you want to control this from anywhere. It doesn't seem to make a lot of sense to me personally. But I am told that consumers really want to control their light switches from anywhere. So, okay. You, as a product development company, figure out, well, there are these stupid things called firewalls, and they prevent me from talking to everything. Okay, that's obnoxious. Well, how do I fix that? I'll reverse proxy the internet connection, which means that this will connect out to some cloud-like device and create a tunnel that I can then connect to from my phone to turn it on and off. It's great. except when you start thinking about security. Or the fact that these companies may not actually be telling you the truth about things. So, on the left there is a rather unfortunately heavily edited photo of a display from one of the IP cameras in my house. I have a number, I believe I have 9 or 10 cameras around my house right now. Mostly because I have 2.5 acres of land and trying to keep an eye on that big of a property is a bit of an issue. But one of the things that I specifically don't want these cameras to do is talk to the internet, because the internet is full of scary, scary things. And so there's this magical line that says platform access, and there's this magical thing that says enable. You'll note that it says it is disabled. This thing should not try to talk to the internet at all. And as soon as I move my big head, you'll notice the dump from IP tables that specifically says, on my IP camera network, trying to access the internet, that device was attempting to talk to this IP address on port 85555, or 8555. That IP address just happens to go to Amazon AWS. For some strange reason, I was not particularly impressed with that device. What's worse is that every IP camera I own, regardless of manufacturer, does this. And some of them don't even give you the nice fiction of being able to turn off that. Some of them don't even give you it. So this is great. We've now put all these neat little devices in our houses. They're lying to us a lot. If anybody's familiar with their update strategy, it's great because they never update them. And there's all kinds of neat other just problems. I mean, they're just, I mean, how many people have something wrong on their laptop right now? Okay, you know, smattering of hands. Think about that when you have, like, you know, instead of like 10 devices on your network, when you have 100 devices on your network. How many of those devices probably have something wrong with them? That you've misconfigured it, you just haven't figured out how Lua works on that particular platform. The vendor stopped supporting it, so it only sort of works now. So, okay, there's some neat things we can do to fix this problem. Or at least maybe not us exactly, but there are some things to fix this. Companies can build better devices and provide long-term updates. That's a pretty solid thing. You know, I paid good money for this thing. It should be updated every so often. You know, maybe once, you know, it's a switch. It's got a relay. You know, maybe update it once a year. You know, I'm not asking for much here. Devices could be more open. You know, hardware and software. In a previous life, I worked for Intel as their open source hardware evangelist. And so I have actually a pretty strong bent on trying to convince everybody that they should be using open source software, which I've been, you know, trying to help facilitate for the last, I don't know, 20-some years. And hardware, because, you know, well, frankly, hardware's gotten cheap enough. We can all build hardware. There's probably a few people in this room who have, you know, literally laid out their own PCB and, you know, gotten stuff back. Case in point. But, you know, be more open so that, you know, we as a greater community can at least come in and maybe help. You know, maybe we won't run your firmware, but how many people have a rooted phone in this room? How many of you are running non-stock, you know, for your particular hardware manufacturers, OS on your, you know, phone, tablet, whatever? Okay, maybe a quarter of the room. Smaller than I expected, I will admit. But, you know, clearly in the phone space, we've all proven that we can, you know, build some, maybe not necessarily always quite as good as the manufacturer, but at least an interesting, you know, remix for your phones. So there's that. Devices can be less reliant on the cloud to spread out the attack surface. This makes sense. There's a lot of good in that sense. And devices can be better, possibly even automatic updates and alerting users about updates. I like updates. Windows just updates now. You know, most Linux boxes, if you're slightly brave, will auto update. Unfortunately, while I'm wishing for, you know, somewhat impossible things out of the universe, I'd also like a unicorn, preferably in green and purple paisley. Because none of this is going to happen. Let's be honest. I mean, when I said the first one, you all started laughing, and you've mostly been, you know, chuckling under your breaths on each of these that I've said. And that's depressing, because we now have a ridiculous amount of cheap computational power that we're literally like connecting to everything. that could like turn on and off our refrigerators and our TVs and listen to us and cackle at us and record our entire movement as the IP camera in the back of the room is doing. This is genuinely kind of scary. And it gets slightly worse when you take a look at what a normal home router looks like. And unfortunately, this is even more complicated than what most people have, because most people don't have the wireless guest network. You know, this is a more recent thing. This is advanced, that we now have a wireless guest network that can't normally talk to the main network. It can only talk to the internet. And this is, you know, maybe a little bit of an oversimplification, but trying to describe networks is really hard. So let me give you an example of what this mostly implies. That we think the internet looks like this wonderful high tea party. You know, everybody's obeying the rules, they're all being polite. You know, why yes, I would like to talk to that port, sir. Would you like a crumpet? Why yes, you know, the tea is lovely. Can I have a thing of sugar? You know, this is what most everybody right now, and maybe not necessarily in this room, because, you know, if you're here, you either want to hear me, you know, song and dance for an hour, which is possible, or you're genuinely kind of scared about how the state of IoT is, and you know, okay, then you're kind of in the right place. But most people who are consumers of straight up electronic devices think that this is the end all be all for how the internet should look, at least from their home perspective. Except that there's, you know, things, they come, they bump into the firewall, and they go away. It's great. That works most of the time. Except that's not the way these things work anymore. You'll remember when I pointed out that the IP camera was continually trying to talk to the internet. Well, that's a problem. Because, oh, yes, okay. I changed that slide. Because this is the way the internet actually looks. It's a mess. And it's a rodeo, and it's the Wild West, and everybody's shooting everybody, and it's really quite deadly. If for no other reason that this device now connects to a random cloud provider of some sort. It then pulls down whatever it's going to pull down. I have no idea how this is authenticating anything, and I have no idea what's running in the cloud. If for no other reason that, you know, let's say that flybynight.com built this device. It did not. I have no idea what flybynight.com is. And they built this, and then they go out of business tomorrow. Well, somebody comes in and buys up their domain name. This is connecting to a domain name, not necessarily that Amazon AWS IP address, because, well, IP addresses in Amazon AWS are relatively ephemeral. Great. So now, because I've just bought up the domain name for flybynight.com, I can do anything I want to this device. That's great, right? What happens when I don't even have to buy flybynight.com? What if I just poison your DNS to the point where it connects to my copy of flybynight.com instead of the actual flybynight.com? ISPs don't, you know, muck with your DNS queries at all, do they? That's never been done before. And for those of you who don't get the joke, they do this all the time. Usually to make money on ads. Neat, huh? Great that we killed net neutrality. Yeah, that's kind of sad. So yeah, so then we infect this magical device that's inside my network with the Ebola virus, which is arguably the most deadly virus known to the human body. And that's great, because now we've just infected our entire network and everything's doomed, and now we're back to the every IoT device is hackable and part of a botnet now. So great. So all of you who have IoT devices in your house, congrats. You're participating in you're probably participating in some botnet somewhere. You know, say hi to the nice people who are controlling it. So yeah, this is bad, to say the least. And this is where kind of the crux of this entire talk comes from, because a number of people have known over the years that my network has gotten more and more ridiculously complicated. And a lot of my friends would argue that I'm just an overzealous systems architect who likes things complicated. They're probably not wrong. But it also means that I've done a lot of things to my network that are weird. This is what my home network looks like right now. You'll notice I have a lot more VLANs than your average consumer. I'm also buying much nicer network gear, unfortunately, as a result, and so my network's expensive. But this also means that I can do a lot of things that we frankly should be doing by default already. This IoT device, there is absolutely no good reason other than the belief that consumers want to be able to control this while they're in Australia, when the device is in America, that they want to control this. There's no good reason. Seriously, it's just a bad idea. But if your oven's on and you're in Australia, call someone. They'll go over to your house and they'll turn it off. Because most people are kind of nice like that, and I'd rather tell people where I've hidden the key to my house that I know and trust than putting this on the internet so that John Q. Stranger, who just happens to find it on the internet, can turn it off for me, or on when I'm not there, and they figured out that I'm not there and they burn my house down. Because, of course, that's never happened before. My IP cameras, and I'm going to kind of blather through this a little bit. But there's some really neat things that we can do here. And yeah, that this is beyond overkill. So my main network has access into all of these things. This is a somewhat dangerous policy, but if you're on my main network, I kind of trust that you're pretty much me, my wife, or somebody who actually literally runs the internet. Because I think those are the three people who have access into my main network who are not me, or who generally have access into my main network. Which means that, from my main network, I can still get at my IoT devices and my IP cameras and my multimedia stuff and my wireless and blah, blah, blah. Yeah, so I can get at all these things, and it's kind of nice. Because I'm me, and I like having access to these devices. But when you're this magical little device that turns things on and off, I don't want you to have access to anything, including the internet. I don't care if you get updates from the internet, if for no other reason than if this can't talk to the internet and it can't talk to anything else, it's probably going to stay in roughly the same state that it started in. And if every device that that can reasonably contact stays in that same state, yes, it may not have the latest and greatest firmware. It may not be able to, it may not be connected to Alexa anymore. But this device can no longer do any damage, or the damage it can do is very limited. It can't get at my laptop, which is good, because things like light switches. These are random devices now that we buy, we connect to the internet, and that can turn lights on and off. They can cackle at us. They can do all kinds of things. So yeah, give me one good reason. Can anybody in this room give me one good reason why that IoT light switch should be connected directly to the internet? Okay, that may be the only reason, sir. And I would argue that you win the prize, but we haven't gotten to the prize yet, so. Yes, so the best reason that this entire room full of, I don't even know how many people are in this room, but there is standing room only in the back, which is kind of impressive. The only reason we can come up with why that light switch, which controls the lights in my living room, should be connected to the internet is to screw with my kid, who's 5.5 months old, who is way easier to screw with at this point than the light switch. But I will remember this for a couple of years from now. So, good on you, sir. Okay, now, I've talked about not wanting my IoT devices to have access to the internet, and yet I have this VLAN that says IoT with internet access. That seems really odd, because IoT things scare me in a lot of ways. So there's some reason for this, and I go back to the generally consumers want access to things. There are a lot of gateway type devices for Z-Wave and Zigbee and all these kinds of things, and the open source ones are all great, except they are about as user friendly as bashing your head on a text console with a brick, which isn't entirely fair to them. Some of these things are actually genuinely complicated and hard to set up and make good UX for, and some of them are eventually going to try and solve this problem. Great. But, hand editing text files to add a new device to my home automation network is not something that I'm going to be able to convince a normal consumer to be able to do. And so most people buy up these devices from various companies. There's a whole slew of them. I'm not going to name and shame all of them. But if you just go to some large online retailer and type in IoT gateway, you'll find plenty of these things. And almost universally, these all connect back out to the internet because, again, people want to be able to pick up their phone, which currently is showing a lovely clock, and be able to turn their lights on and off when they're not at home. Which, again, if you have consumer friends who believe this, please, sit them down and ask them why they want to turn their lights on and off from Australia. Because I'm still not convinced that any of them have any better excuse than they want to screw with their kids. Because, we have a new idea on that front.
Protection from an actual criminal trying to break into your
Okay.
home. It tricks them into thinking somebody's there.
Correct. But if you're home, frankly, you're already on your home network, and if you're not there, you probably don't know they're there anyway. But your point of using it to scare off an intruder is a potentially valid use case. Although, in some cases, if your home automation network is complicated or sophisticated enough, it would be able to detect movement when you're in an away state and then automatically just turn the lights on, and then maybe, in an hour, be able to email you or text you or something. It may make slightly more sense. But, automated to a random time also works. So there are some ideas here, but realistically, at best, the best one I've been able to find that does the least amount of communication with the internet is a device I have in my house, which is from a company called Vera. They've had various names over the lifespan, and it's a pretty decent little device, except when the eMMC on it fails and they don't tell you how to reflash the device over TFTP or anything. It's kind of obnoxious, but it does everything locally except for one thing. All authentication to the device happens at the cloud. So I can still go to the IP address for my device, and I can turn my lights on and off, and I can check the temperature. But if I want to clear out an alert, that somebody moved in my pantry or something, I have to go and authenticate to their website that then kicks me back to my device with a token shoved into my browser. It is the most depressing thing I can think of, if for no other reason. Everything else runs locally on the device. It doesn't need any other internet access. And yet, that is the best device I've found. The worst is, strangely enough, things like this. And you'll note at the bottom it says prize time. This is a switch that I bought off of Amazon, or your favorite large online retailer, that claims to connect to Wi-Fi. I'm like, great. There's a few more things in my house I would like to connect to things. Z-Wave's obnoxious. Zigbee's also obnoxious. Wi-Fi, great. I know how to deal with IP. Great, so I bought this. Guess how you control it? It only works through the cloud! Awesome. There's this entire instruction manual, which I did bring with me, that explains how you install an app on your phone, which, by the way, hasn't been updated since 2015. So it's totally secure. And the only way to get this relay in this device that's now connected, or that is not actually connected to my Wi-Fi network, because I figured this out quickly enough, that the only way to connect this to anything is to log into Amazon, or to let it log into Amazon AWS, and you click a button. So the person at the end of this talk who comes up with either the best question or the worst question, I haven't decided yet, wins a prize. And you may take this home and you may do whatever you want with it, because it wasn't worth my time to ship it back. And that should tell you how cheap these things are getting. That I think I spent like $10 on this thing, and it wasn't worth my time to put this back in a box and ship it back. And yet here I am, I'm getting a good solid laugh out of it, that I'm going to give this away today to some either very happy person or very sad person, depending on their perspective. But yes, these are the devices we're putting in there. And this is why my network is as complicated as it is that the interactions that these devices have is insane. Why does my light switch need direct access to my IP cameras? Why do my IP cameras need access to anything? And yet these are full-blown Linux computers that have Buildroot and Yocto installed on, or Yocto-based distributions installed on them. These are non-trivial kinds of devices at this point. They're almost as powerful as your phone. And that should scare you that that these things have gotten so cheap, so powerful, and yet we're just putting them on the internet and letting them talk to random websites. They've got a gig of local storage that they could do things with, because IP cameras they sometimes store things locally, at least for a set amount of time. This is insanity. And so yes, I take my IP cameras and they get shoved off onto their own network. And part of that reason is that, again, since I have a little one, why would I want to give anyone else access to the ability to look at my son while he's sleeping? That is a genuinely creepy thought. That, just because I want to make sure that my son is still breathing at 3 in the morning and I really don't want to leave my bed because it finally just got warm. How many of you are parents in here? My son is 5.5 months old. I sympathize with all of you on those late night feedings now. I grok. I did not grok before. Those of you who do not have kids, you do not grok until you have them. It's I love my son dearly, but gosh darn it, could he sleep through the night once? My wife's gonna kill me. I know. Somebody's. Oh, soon, yes. Well, hopefully sooner than later. But yeah, sadly my wife is stuck dealing with his overnight feedings right now by herself. So hopefully I don't return home and be killed. But yeah, I mean, this is the kind of stuff that we're doing, and this is one of the specific reasons why people are putting cameras in their homes. People are putting these voice assistants into their homes. These voice assistants do not stop listening to you. If you have a voice assistant on your TV, it does not stop listening to you. It is listening 100% of the time, because at some point you might say the magic word, and for some strange reason, the universe doesn't work that it can trigger an interrupt that says you should wake up now. They said the magic word. No, the way that works is it just listens forever. So if you have one of these devices that you can talk to and say things to and convince to go into an infinite loop, if you have enough of them, these things don't stop listening to you. And if you have a smart TV and it has a camera in it, there's nothing that you can really do to prove whether somebody's actually looking on the other end of it, whether you're watching TV or not. Because there's no video cameras on like laptops and whatnot used to have the LED that was attached to them used to be attached to the power line, and so they would only be on when the power was applied to the camera. It's not the case anymore. It's just a soft LED, which means if you want, you can come take a look at my laptop. You'll notice that the camera has a cover over it. And if you don't have one of these, I highly recommend them. They're not that expensive. They're usually cheap plastic, or you get them free at conferences. I'm sure when the exhibit hall opens tomorrow, somebody will be giving them away. And yeah, yes. So if for no other reason, I wanted to point this out and try and get people to think about this. And that's the reason that this talk, when Scale asked me to do this talk, is they wanted me to kind of explain why I was insane. And the real answer is I'm not exactly insane, I'm just paranoid. And when you've run kernel.org or a large internet infrastructure for a decade, you get paranoid. Because, these are, the target on your back is much larger than the target on most people. But it also means that you're more aware of what that target means than your average person. And so they asked me to kind of come and explain, why does this make sense? Why do we need this? And this is frankly why. And there are some neat tricks you can do, depending on how you set your network up. So you'll notice that my wireless network is not necessarily directly connected to my main network. It is on its own VLAN. And that is because I bridged the two VLANs back at the router. Because, for two reasons. One, you can filter IP traffic on a bridged network. which means that you can filter traffic as it crosses the bridge. This is really neat for a number of reasons. Because you can, let's say I'm on my wireless network, and I don't want somebody on my wireless network, regardless of who they are, to have access to the IoT network. But I do want them to have access to my Chromecast, so that, they can throw things onto the TV and make, pretty cat pictures or something. Well, great. My wireless network now routes back through my router. I can block the traffic appropriately, and everything's still on the same broadcast domain. Because, again, most home systems, and a lot of systems even in business, all assume that they are on the same broadcast domain. What this basically means is when I, scream out into the void, I'm on this network, everything else goes, we know. Shut up. But when you're on different network segments, when I scream out, I'm on this network, the Chromecast, if it's on a different network, doesn't tell me to shut up. It just goes, I didn't hear you at all. And that becomes a complication. So this is a neat way that you can get around segmenting things into different, VLANs and, domain groups to help with your security. So, if you want to follow in my insanity, which you may or may not want to do, there are some tricks that you can play here. You do have to have pretty much full control over your router, which means you're not running, stock routers anymore. I'm sorry, the OpenWRT stuff's not going to cut it anymore. But there are some very lovely small board computers that can do all of this, and Linux and, FreeBSD and all those kinds of things. They all work great. But there's also some interesting problems when you get into the wireless guest network. Because I still want the random people who I actually allow into my house and then onto my network, the guest network specifically, to have access to my my Chromecast, because they may want to show me pictures of their cats. For the record, I'm deathly allergic to cats. I don't know why I'd want to stare at them, but everybody tells me that I should look at cats. So, how do you solve this? Because you don't want them on the same broadcast domain, because that's bad, because then they can guess all kinds of things about your internal network. But you also want to be able to give them access to your Chromecast. Well, there are a lot of neat ways to solve this, and Avahi, if you're all familiar with it, does have some ways of repeating broadcast traffic and doing it in a filtered way. Effectively, you're doing MDNS at your router. This works great. If you have devices that don't play with MDNS correctly, you can always set up tunnels, little software tunnels across the networks at your router. And this all works. Works great. I am living proof. If for no other reason than I haven't had any complaints in the last 6 months of things not working on my network from the users who come and have very strong views on this. So, yeah, this is all a mess. I've got a little bit of time for questions, but before I give you the opportunity to win this fabulous prize, there are some things here that I want everybody to kind of take as a take-home. I may not have explained them nearly as well as I would have liked to in this talk, but I only have an hour, and this is an insane topic, mostly because I'm explaining my own insanity. And yes, my network is likely way overly complicated for what we actually need. There is, in some respects, no reason for me not to just lump my IP cameras in with my IoT devices and just accept that they're all one type of mess. I bought high-end network gear. I can have, 512 some VLANs. VLANs are free. I'll just do that. And if the equipment we were putting into our houses was nicer and we had better infrastructure available to people, we could do things in even more clever ways. Things with like WPA2 Enterprise. When you authenticate to a WPA2 Enterprise device, you can actually set VLANs based on that authentication, which means you can expose one SSID instead of the 6 I'm exposing at my house. And then you can route things into different VLANs. But that means that this type of device needs to be able to talk WPA2 Enterprise, and most of them don't. So that is a thought. We need to do a better job of educating users. And by users, I mean probably not the people in this room, because you're all very smart, you're sitting in this room. we need to explain to users that, you know, their network topologies, as simplistic as they are, don't work anymore. They're fundamentally not safe, particularly if you're adding IoT devices to it, because the IoT device will be the infection point for your entire network at this point. And if you have them, I guarantee it. And it may not just be because, you know, you may go to a website, the website will launch a bunch of JavaScript, it will go and probe your internal network, find the IoT device, and then infect it. And this is a known attack. So please run ad blocker. If you're not already, please. Home networks are no longer simplistic things. They can't be. The belief that they are is just silly. Most users don't understand what they're actually getting into. Frankly, most of us don't know what we're getting into with networks, but that's a different problem. And we have to be better at every level about the defaults that we give to users. So if you're working in projects like OpenWRT or router stuff, or you're building products, take a look at what you're doing and seriously ask, does this make sense? Why is there not a default IoT network exposed by every router on the planet now, so that I can connect this stupid device, I mean, stupid in every sense of the word, to the internet, and then it can't infect things that don't make sense to infect. Yes, it may still participate in that distributed denial of service attack, but at least it can't do any more damage to the things I actually care about, like the baby photos of my son. Something to think about. And while a lot of the things, when I showed you my network, they're very complex, it's not something a lot of people would even think about trying to set up, because VLANs are almost mystic knowledge, depending on what switch you've got and how you set it up and where in the configuration, and it's not simple. We all have to think about how we can take these incredibly complicated things that we know this stuff can do, and we have to get it to the point where it's simple enough to understand that any of us can use it, at least at the most basic level. So, this is my fear-mongering talk of the year. And at this point, I thank you for sitting through me being silly. And if you've got questions, I think we've got a mic that we're going to, I may run around or something. Actually, if you have questions, line up behind the projector. We do this at work, so. And I will badly answer your questions in the order in which they are received. So.
Is there a way to turn off the mic on like my laptop and the TV, since I don't need it actually listening, and so someone else can't turn it on?
Desolder it?
Destroy it.
Yeah. Poke a hole in it, do something. I don't have a good answer for that, because laptops are designed in such messy ways. What? There you go. Purism is creating devices that have physical hardware on-off switches. So take a look at their stuff. It might, yeah, an earplug or something just shoved into the mic. Yeah. So, yeah. I don't have a good answer for you because it's hard. You could, but what does that mean?
If you want to use it again, you got to go back to sit around.
But just because software tells you it's disabled, is it? That's the gotcha. Is that you can't from.
You're getting your hardware. That's it, aren't you?
It could be connected in any number of ways, and so the answer is valid, or the question is valid. I don't have a good answer for it. Desolder it is the best answer I can give you. But I'm not a security person, and I might be overly paranoid.
Two questions.
Yes.
One of them is there some, internet place where something is posted as to what would constitute due diligence for a ordinary person to have reasonable security, some value of reasonable security at home? Number one. Number two, if such a thing exists, how many man-hours per year would it take for the person to invest to actually make that work?
Ooh.
including learning how things are changing. Thanks.
Oh, okay. So the answer to your first part of your question is I do not believe that anything exists, but frankly something should. And now I think I'm stuck being the last one touching that idea, which means that I'm probably going to have to go do that. Because this is the way the universe works. The last one touches it, they're it. And two, I don't have a good answer on that, but rough need.
Less than the number of hours per year you're spending on software.
Well, my knee-jerk reaction would be if somebody goes and takes a look at, some sort of updated document, maybe once every 6 months, and just sees, even if there's just a diff of what changed since the last time I was here that I should be doing differently or better or something, that might be good enough. So initially it may be a lot of work, but the upkeep should be once my VLANs have been set up, it's not like I've had to do a whole lot to continue that security model.
But what if your wife is also
Yeah.
But if an ordinary person
Yep.
buys something
Yep.
at Bed Bath & Beyond off the shelf,
That beyond section.
and they plug it into the wall,
Yep.
they're not a computer person, not a software person,
Yeah.
how much do they have to invest to acquire the skill to even do due diligence?
I don't know. That is it's an excellent question. I just don't. I genuinely do not know, and I'll have to go think about that. So
So I don't know if it's a comment or a question, but seeing you express ideas that you might be paranoid using all these VLANs, what convinces you that you are safe with a VLAN in that with an embedded device? I don't see what stops them from crossing the VLAN barrier or crossing a Wi-Fi barrier either, for that matter. If they've
Correct.
got a Wi-Fi transmit receiver, how do you know what's running on it?
So the simple, how paranoid is John? Is I think the simplest way to put that question. At some point, you have to draw a line on how far down the rabbit hole you want to go, because if you keep going, you go all the way down to I need to make my own computer chips. And by I have to make my own computer chips, I mean I have to build my own fab from the literally dirt to 20 nanometer fab. So that I can build my own chips. So yes, there are attacks on VLAN hopping and all that kind of stuff. I'm mostly expecting the people who are doing these attacks, the botnets and whatnot, they want to go after low-hanging fruit. I want to make myself so un-low-hanging fruit that they either can't figure out what I'm doing and go away anyway, or that I don't fit into their logical model, and I become too much of an annoyance, and they literally just go away. So yes, if I convince everybody to do this, I've literally lowered my own safety threshold, because now I've made everyone, I floated all the boats, which means now the low-hanging fruit is much closer to me. Yeah. Yes, I don't need to be the fastest person. I just need to be faster than the last person to outrun the bear.
You sort of answered my question a little bit, but you have that device on you that's there, and I was wondering, there's got to be other companies that are producing, I guess, being more responsible, making IoT devices. Do you have any recommendations?
Oh, okay.
Like brand-wise, because I know
there are some. Okay, the best answer I can give you to that is go and take a look at the devices that Home Assistant specifically. Home Assistant's an open source project that does gateway kind of stuff. If they support it, the company is at least giving you is likely either giving you direct access to the device via your local network, and that should be mentioned probably somewhere in the description, or they're giving you an API through their cloud. If they're giving you an API through the cloud, you'll probably need some sort of API key when you would set that up, so that should be pretty obvious in the documentation. That is not the device you want to buy, unless you trust the magic of the cloud.
Well, I'm wondering more like what companies should we be supporting to try to...
There's two, the two switches I have mostly in my house right now for that are Wi-Fi based. TP-Link has an excellent one that is you can completely control directly on your own network, no cloud access necessary. And there's Sonoff, Sonoff. S-O-N-O-F-F, I think.
I've heard
Yeah.
the relay,
Yeah.
but you still have to set up like something else to control them.
Yeah, you still need something like Home Assistant, or if you're willing to, give Vera a little bit of internet access and a little bit of access to your home, those kinds of things work. Otherwise, we should probably be looking inside the open source community and trying to help projects like Home Assistant get better.
Okay, so the other thing you mentioned was the WPA2
Yep.
Enterprise. So try to look for switches that have that.
So the most wireless access points do support WPA2 Enterprise. The things you're going to want to look for, like if you're looking at access points, are going to be whether they support VLAN tagging based on WPA2 Enterprise. I know that things like devices like Unify do support this, which is from a company called Ubiquiti. But the gotcha is that you need to be able to support the authentication scheme that WPA2 Enterprise needs, and that requires Radius, and Radius is kind of a pain in the butt to set up. So it's a really good idea that's, like, even for me, is relatively obnoxious to try and deal with. And I haven't quite gotten my setup working yet.
So you're basically telling us if we're in the market for anything, just wait for the next generation or...
I'm not saying wait for the next generation. I'm saying go buy the stuff that's there now and help us fix it. Don't wait. Come help.
Hey, so with IPv6,
Yes.
it seems like people don't really run NAT anymore.
Nope. NAT fundamentally should die with IPv6.
Okay. And like devices are a lot more uniquely addressable
Yep.
on the internet. So the question is, do you see this as, helping or hurting the problem?
Oh. So I have very mixed views on this because having run large internet infrastructure, having a flat topology makes everything easier and better. However, also having devices sitting on my home network with IPv6 scares the bejesus out of me.
It's kind of like you're losing a layer of firewall.
You are fundamentally losing a layer of firewall, but NAT is fundamentally a lie anyway. So all we're really doing is we're getting back to what we should have had in the first place. More or less what that means is that you just have to be more diligent about your own firewalling. And this isn't to say that, having this pingable on the internet is a great idea. Yeah, that may not be, and you should be able to stop that at your firewall. Or you just assign it, there are private IP ranges that are specifically non-routable and non-NAT, I believe they're supposed to not be NATable, so local link layer IP addresses that you could assign to this so that it doesn't talk to the internet.
Do you think home routers should block incoming connections by default?
Yes. If your router is not blocking all incoming connections by default, go home, throw it in the trash because it's not even remotely doing its job. Yeah. Yeah. So there you go.
You made this nice picture of people thinking that the internet is like a coffee party. But the fundamental problem is it's not just that people think it's like that, but also that the original designers of the internet thought the internet would be like that.
Yes.
And so I believe that the real approach, or one other approach to solving this problem, is that we completely redesign how networking is done.
I won't disagree with you on that. The gotcha is IPv6 is already effectively deprecated, and it's taken us 20 years to get to this point. And how many people in this room have IPv6 at their house? Yeah. So I don't disagree with you. This is something we could fundamentally fix by taking everything we know about IP, throwing it out, and starting over. But that will be completed sometime around 2100.
I'm working with a project which is trying to attempt to that, and I'll actually have a talk on that on Saturday.
What's the project?
It's called the laptop. I will talk about it. The talk is called Let's Fix the Internet.
Okay.
I hope you will be there and
I will try.
Give me some feedback of what you do.
I will try. So there you go. Pitch for his talk. Let's fix the internet by burning it all down. Let's fix the internet is the talk. It's on Saturday, he said. So 3 o'clock.
Hi. You had mentioned OpenW.
Yeah.
Didn't
quite do everything you want it to. I wondered if you had any kind of recommendation for
Okay, so from a hardware perspective, it gets really complicated. Probably the best thing I can suggest to you that is off the shelf, that can do everything that I've kind of described, that has a user interface that is not like, please edit this text file, please edit these 20 text files to make this firewall work, which is what I do. Pfsense, which is an open source project. There's actually commercial support, and you can buy specific hardware that does all of this. I think it's store.pfsense.com or something like that. The boards are sold from built from a company called Netgate. And those OpenSense? Okay. Okay, so apparently Pfsense doesn't build properly. Thank you. I will go bug I will go bug some people about that. Actually, I probably know what they're doing. So anyway, but yes, OpenSense or Pfsense. Just go take a look for those. Those are the things I would probably recommend. If you're much more comfortable with the command line and you like hacking on things, my firewall is entirely based on IP tables with a wrapper called Shorewall. And I just run it on literally just a random x86 box that I basically pulled out of the trash, and a couple of 10 gig NICs that I threw in it. So, yep. Yes, I did mention Ubiquity. Their firewall does not do what I want it to do. But their access points and their switches are pretty decent.
Okay, for your Wi-Fi device.
Yes.
So your cameras, et cetera, you got them on, you're segmented.
Yep.
So what happens if somebody can show up with a open Wi-Fi connection and get them to VIP? Do they, even if you lock them down, do they suddenly start checking in with the mothership?
So let me rephrase your question and see if I rephrase it correctly. If someone knows my SSID is being broadcast, so everybody knows what my SSID is, and if somebody was to know what the password was for that particular network segment, which one would hope that they don't, but let's say that WPA2 has a giant crack in it.
The only thing to do is to knock your network down and stand up an open network.
Yeah.
If you've got 2.5 acres,
they've got plenty of space to do it in.
I went to Seagull, and there was one she was working on a coal area, and people had to go up a hill that she couldn't climb in order to steal her dish, but they gave her access to her network.
Yes. So if somebody was to fake enough of my network or something to get those devices to actually reconnect back out to the internet, yes. There's not a lot of ways that we can stop that particular problem other than one would have to hope that the device, once it's connected to the network, would try and attempt to forcibly only connect to the way it's expecting. So, if you stand up an open network, one would hope that it doesn't actually just, fail over. That's not to say that that wouldn't happen, but now I'm curious, so I'm probably going to go home and try this. And then be like, oh God, it's all broken, and this will probably turn into a Pocket DEFCON or something? I have no idea. But,
I got a TV, I connected up to it, and that cable got an update, disconnected network cable, but I have no idea what the Wi-Fi is doing.
Correct. Well, it's fundamentally the same problem of if you own a large house or whatever, and you've pulled Ethernet to the outside, like, I don't know, they connect to your fiber, there are problems of, well, what happens when somebody comes up, pulls that connection, and plugs a different one in? It's more or less the same problem. There are ways around this. 802.1x, WPA2 Enterprise should fix that in the general sense because of how it authenticates, because it's basically 802.1x. But WPA2 Enterprise, if you're flipped over to it, it won't connect unless it authenticates correctly. So, but that's Enterprise, not PSK. And I don't know what happens with PSK, so yeah, now I'm curious.
Do you have any MAC validation behind that?
It would have to be at the device layer, and the problem is that getting access to these things is almost impossible. These I effectively have to treat as a black box that we will never be able to fix. At least that's the way I look at it. Well, yeah, it's a pain in the butt, and it's trivial to spoof MAC addresses. In fact, most of your phones probably are randomly assigning their MAC address as they connect to the network. So, anyway.
More comment.
Yep.
Asking about big brands doing IoT security, right?
Yep.
I'd recommend reading Matt Garrett's
Yeah, no, that was, it was the connected Barbie. It was it Matthew Garrett? Yeah, it was Matthew Garrett, who did the teardown. And they actually did genuinely do a bang up job on that. So, if you're ever curious, that's actually a really good read. So, if you're building IoT devices, that's a way to go and look. So.
What's your opinion about IoT devices that provide their own access points? I mean, but my neighbor is watching some
So there's a couple of IoT devices that are running around right now that effectively provide their own access points. My Vera, for instance, has my Vera actually runs OpenWRT, which is why I'm slightly annoyed that I can't convince them to let me have the bits to reflash it if I needed to. But I haven't really tried very hard on that, so that's a different problem. There are things like the Fire TV. The remote for the Fire TV these days does what's called Wi-Fi Direct, which means that it's actually broadcasting its own Wi-Fi SSID to do connection with the remote. And there's a bunch of things like that. It's probably bad. In the grand unified universe view, it's probably bad because now it's poking holes in a security layer that you don't control necessarily. So like the Vera, I've actually turned off all the ability or all the access point abilities on those devices in my house, mainly because I have much nicer access points than what they'll ever provide. But things like the Amazon Fire TV with its Wi-Fi Direct, well, how am I? I would like the remote. The remote makes this usable for me, but how do you? Is Bluetooth really better? Is Wi-Fi better? I don't know. And there's just the devices that bring their own access point for whatever reason, whether it's Wi-Fi Direct or they believe that they should be the one true gateway for everything. I think they're probably misguided, at least in some sense. Now, I do have some faith that Amazon, if they do get hacked for whatever reason or their Wi-Fi chip has an issue, that they'll push an update because, frankly, I think they have slightly better hardware engineers involved. But I can't say that necessarily about all the companies involved that do these kinds of things because, who knows? Maybe the device that I bought today that, I don't think I bought any devices today. But if they ship an access point in their device, how do I know that they'll get updates? How do I update it if it's a problem? How do I even disable it? Which goes back to the question about how do I disable my mic? Well, how do I know that the Wi-Fi chip on my Vera is disabled? Well, I don't see any SSID broadcasts that would match anything to it, so I'm reasonably sure it's off, but that's not absolutely guaranteed unless I go in there and I rip the Wi-Fi chip out.
So the issue is that a lot of vendors, they want people to be able to quickly configure their device.
Yep.
And that's why they're doing that.
Yeah, no, it does come down to how do you reasonably authenticate stuff? And yes, if they provide their own access point, and if you've got to go over and push a button so that it sets itself up and then pushes some data, I don't know. That may or may not be a good thing. And some of that's just going to be if you look at it and your risk assessment says that is a scary thing, don't buy the device. Again, some of that does come back to how paranoid do you want to be. Yeah. And then I got to decide who.
There are some IoT devices which one are coming with GSM embedded module inside of them.
Yeah.
And the internet also box. What do you think about that?
Yeah. So there's a lot of neat devices these days because GSM has gotten so cheap in some cases that in fact I'm backing something on Kickstarter right now, which is a little device that you slap it in the back of the mailbox, the ones that have the key and everything that are like up the street from you, and then tells you when your mail came. They're doing light sensors and scanning and all this other kind of stuff, which is neat. Because and you can buy up the credits for the GSM for a year, and they're like $5 or something like that for the GSM credits. But yes, how do you protect against that? Effectively, if it's on the GSM network, or if it's on the public internet, or on the Wi-Fi here, even you basically have to treat it as a public device. That it is just out there. If you want to trust it with anything, you're probably insane. Now, if you want to just believe that, you know, it told me that my mail came, you know, yeah, and everybody else on the block. Oh, that goes back to the Amazon door thing. Yeah, it's neat. I like the idea, but it's going to suffer from the same problem of, you know, the connected car, the mailbox generally will not kill me unless somebody else has done something else malicious. But don't do those things. That's bad. So, I think I'm going to give the prize to the answer that I could answer, or to the question that I could answer the least. So, congratulations, sir. You want a prize? You may do with that as you wish, and up to and including thermiting it, which I would probably recommend. Anyway, let me get to the end here. Again, my name is John Hawley. That's my contact information. These slides I will get up to scale, and they are CC by SA, except for the pictures. Those are all copyright respective whoever they did it. If it does not have a copyright notice, it's probably my picture, which is probably CC by SA. So.
Okay, thank you. We'll be doing more embedded tomorrow in this room, starting at 10. Thank you.
So, we knew that the cameras were insecure to begin with, and so